Hey everyone, welcome back to our 8-week course on how to build a basic FTC robot. This is our third class so far, and if you haven't watched the other two, please make sure and watch them before watching this one. They're linked in the playlist below in the description. Today, we're going to be talking about drivetrains, what they are, and what they do.
So first we're going to talk about some basics of drivetrains. So for your drivetrains' rotations per minute, different motors will have different gearboxes, which mean different RPM or rotations per minute. Higher RPM usually means less force. For a defensive robot, which would push others around and have a really strong design, you would use motors with lower RPM, which will allow it to push other robots around and push game elements with a lot of force. However, if you want a faster, more offensive robot, you would use high RPM motors, which will allow you to drive around faster and get more tasks done in a lower amount of time. In our experience, a well-balanced drivetrain has wheels moving at around 300 RPM depending on your wheel size and type. Attaching the wheels directly to the motors is generally bad for the motor, so you should use gears, sprockets, or pulleys to attach them. However, be careful as these can also be used to change the RPM if you want to change drivetrain behavior, so make sure that you're not intentionally changing it. Most drivetrains are powered by 4 motors and have 4 wheels.
So I'm going to be talking about different types of drivetrains in FTC and the main types of drivetrains that are used on FTC robots. These are mainly the simple ones. Of course, there are exceptions, but these are the main basic ones that a lot of teams use. So first is the tank drive, and it consists of 6 wheels, 3 on each side, or maybe even 4 wheels, 2 on each side, and it's pretty fast and stable. The wheels are usually regular wheels or maybe omni wheels, and the tank drive has a small turning radius. When both sides move in opposite directions, it turns has a very tight turning radius. The tank drive has a lot of traction, and that allows it to push and pull other robots around as well as push and pull game elements around. However, the only con of tank drive is that it's not very agile, as it can't strafe left and right perpendicular to its main line of movement. The next type of drive commonly used in FTC is a holonomic drive. This is made up of 4 omni wheels placed at 90-degree angles to each other, and it allows for movement in any direction without turning. Here is where it gets a little complicated, and we'll probably show a diagram of how you can move in different directions with the holonomic drive, but the main point is that using a holonomic drive allows you to move in all directions without turning. So you can move left, right, forward, and back. And the reason this is because omni wheels can slide perpendicular to the way they rotate, so they can slide around. The only problem is holonomic drives have low traction and low torque. This is because they don't have as much traction. The omni wheels don't have as much traction with the ground, and in some directions, you're only using 2 motors to go in that direction. So that makes it have low traction and torque. And also it's low speed, once again, because it has low traction. Another problem with holonomic drives is it takes up a lot of space due to the wheels' angles, because the wheels have to be 45 degrees to the main direction of movement in order for all 4 motors to be moving when it goes forward. That means that it takes up a lot of space, and the wheels, mounting the wheels and mounting the motors takes up a decent amount of space because they're 45 degrees to the main robot chassis. So the last type of drivetrain that I'm going to be talking about is the Mechano drivetrain. The Mechano drivetrain uses 4 Mechano wheels and is arguably the most used drivetrain in FTC since it allows for movement in all 4 directions. It's pretty easy to use, and it has a decent amount of traction when compared to the holonomic drive. So the Mechano drivetrain uses 4 Mechano wheels, which is a special type of wheel that has rollers 45 degrees on the wheel. The Mechano wheels are positioned the same way you would position a tank drive, wheels on a tank drive, so there'll be 4 in each corner. The Mechano wheels allow the robot to move side to side when you power the Mechano wheels in certain directions. And this Mechano drivetrain has minimal friction, and it also has a decent amount of traction with the field, so you can push and pull around game elements, but it doesn't have as much traction as the tank drive. Mechano drivetrains are easy to build, as previously mentioned, but they do have slightly lower speeds when compared to the tank drive, and strafing isn't as fast as you would be strafing with the holonomic drive. And as previously stated, because Mechano wheels have a lot of traction, they can't be pushed around as easily, so they can be like a bit of defensive robots. But a tank drive would generally be better for that purpose.
Thank you for watching our third class in our 7-week Intro to FTC Engineering video series. We hope you learned a lot, and we also hope that you continue watching our series and watch the next video when it's released next week. Thank you for watching, and all the links that we talked about will be in the description.